Welcome to the Deep Dive. Today we're plunging into, well, a really fascinating scientific mystery. It's brewing in Antarctica, of all places.
One of the most remote spots on Earth.
Exactly. And imagine this. Scientists are seeing particles that seem to just, I don't know, appear out of nowhere, shooting upward from the ground.
Which seems to defy well-known physics.
That's a genuine head-scratcher. So, yeah, let's unpack this. Our deep dive mission today is to explore this really quite astonishing anomaly. It was detected by a special particle detector called ANITA.
Right?
We'll try to uncover what exactly they saw, why the most straightforward scientific explanation sort of completely collapsed.
Yeah, it just didn't hold up.
And what, mind-bending possibilities this opens up for how we understand the universe.
And, this isn't just some quirky little observation buried in a journal somewhere.
Yeah.
This is potentially a hint at something fundamentally new about how everything works, so we're going to guide you through the implications.
Help you understand why this particular puzzle has physicists, well, buzzing.
Definitely buzzing.
Okay, so let's start right there. What exactly did ANITA see? First off, ANITA, that's the Antarctic Impulsive Transient Antenna.
Quite a name.
It is. And it's basically this detector, but with a really unique setup. It's hanging from a giant balloon floating way up, maybe 40 kilometers above the Antarctic ice.
Way up there.
And its main job is listening for radio waves. These are like the screams, if you will, from really high-energy particle interactions happening way down in the ice.
Kind of like cosmic whispers, but loud ones.
Exactly. But then came the discovery that, well, it threw everything for a loop. ANITA detected particles, but they weren't coming down from space like you'd expect. No, they were emerging from the ground and racing upward through the air.
Upward, which is just weird.
You can imagine how unexpected that is, right?
Yeah.
Because cosmic particles, the ones we study, they almost always come from space. They travel down.
Always down. Or that's what we thought. And these weren't just any particles either. These were incredibly powerful events.
How powerful?
We're talking energies around an exaelectron volt, an EV.
Okay, what does that mean in, real terms?
Well, an exaelectron volt is 10 to the power of 18 electron volts. That's roughly, get this, 100,000 times more powerful than the collisions we make at the Large Hadron Collider.
Wow, 100,000 times. That's huge.
It's enormous energy. And crucially, this wasn't just a one-off blip. It happened twice.
Twice?
Yeah. Once during ANITA's flight back in 2006, and then again 8 years later in 2014.
Okay, so it's repeatable, potentially. And this is where the mystery really bites, doesn't it? Because normally everything comes down. Why would something, anything, be shooting up from the Earth like that, especially with that much energy? The standard picture for cosmic rays is pretty well understood. They smack into the upper atmosphere.
Right, create showers of secondary particles.
And those showers rain down on us.
Yeah.
Now, I guess the immediate thought for physicists might be, okay, what about neutrinos?
The ghost particles.
Yeah, those weird little things that hardly interact with anything. Could they be involved somehow?
And you're absolutely right. That was the first thought. The, let's call it conservative explanation.
The safe bet.
Kind of. The idea was, look, neutrinos barely interact, right? So maybe a really high-energy neutrino could shoot straight through the entire Earth.
Through the planet.
Through the whole planet, yeah. And then, just by chance, it hits an atom in the Antarctic ice, but from below.
Okay.
And that collision could then eject particles upward. And maybe those are the particles ANITA detected.
So the neutrino comes up from underneath, basically.
Exactly. It seemed plausible. It was the leading idea for a while.
Okay, so that sounds like a reasonable theory, at least on the surface. But science isn't about just accepting the first reasonable idea, right? They had to test it.
Precisely. You need evidence. You need to verify.
So how do they go about checking if this neutrino idea actually held water?
Well, they turned to another experiment, a really big one called the Pierre Auger Observatory down in Argentina.
Auger, right. I've heard of that. It's huge.
It is. It covers a massive area, and it's been collecting data for, over 15 years? Much longer than ANITA's flight times, and it sees a much larger area of the sky.
So the logic was?
The logic was simple. If ANITA's upward events really were caused by these Earth-traversing neutrinos, then Pierre Auger, being so much bigger and running for so much longer, should have seen loads more of them.
How many more? Did they have an estimate?
Yeah, the calculations, the models, they predicted Auger should have seen somewhere between, say, 8 and 30 similar events over its operational time, based on the ANITA detection.
Okay, so between 8 and 30, that's a pretty specific prediction.
Yeah.
What did Auger actually find?
Well, this is the crucial part. Auger looked through all its data, 15 years worth.
Yeah.
They found only one candidate event, just one. And even for that one, they had low confidence it was actually the same type of phenomenon ANITA saw.
Only one, maybe. Yep. When they expected maybe 8 to 30.
Exactly, which, effectively rules out that standard neutrino explanation. The numbers just don't add up. Not even close.
Wow, so that's big. The most plausible, maybe the most boring explanation.
One everyone kind of hoped might be true just to keep things simple.
It just collapsed.
Pretty much, yeah, with high confidence.
So, okay, what does that mean? If it's not standard neutrinos doing this weird journey through the Earth, where does that leave us? We're back to square one, facing a true enigma.
It leaves us in a very exciting place, actually.
Exciting how? Because the simple answer is wrong.
Exactly. Because if the conventional explanation is out, it opens the door. It forces us to consider, well, new physics.
New physics. Okay, that sounds dramatic. What kind of possibilities are we talking about here? Are scientists just throwing wild ideas out?
Well, they're speculative, yes, but they're being taken seriously now because the standard model explanation failed. We're talking about things like sterile neutrinos.
Sterile neutrinos. What are those?
They're a hypothetical type of neutrino, even more elusive than the ones we know. They basically only interact via gravity, theoretically.
So they could potentially zip through the Earth even easier.
Maybe. Or they could interact differently. Or perhaps it's supersymmetric particles.
Ah, CSY. The theoretical partners to all the particles we know.
Right, predicted by supersymmetry theories. These particles, if they exist, could have entirely different properties, maybe allowing them to cause these upward bursts.
Okay, what else is on the table?
There's even talk about dark matter decay.
The invisible stuff that makes up most of the universe's mass.
Yeah. Maybe some component of dark matter is unstable and it's breaking down, decaying, and somehow triggering these events in the Antarctic ice.
So dark matter isn't just sitting there, it might be doing things.
It's a possibility being explored. And, people also looked into more mundane things like weird ice properties, refraction effects. Could the ice itself be playing tricks on the detectors?
Like a mirage.
Sort of. But that seems less likely to explain the high energies and the specific signal characteristics ANITA saw. These other ideas, sterile neutrinos, SUSY, dark matter, they seem like stronger contenders now. It's interesting. The lead author on that Pierre Auger paper, the one that basically ruled out the standard neutrinos, he actually described their own analysis, their paper, as maybe a 1 out of 10 on the excitement scale.
Really? Why? It sounds hugely important.
Because it was just dry data analysis, crunching the numbers, ruling something out. It wasn't a discovery of something new.
Oh, okay.
And this is the key point he made. That dry analysis, that ruling out, is what makes it so crucial. It slams the door on the ordinary explanation.
And forces open the door to the extraordinary.
Precisely. The mundane failing makes the reality potentially much, much stranger and more exciting. It clears the path for unknown physics.
Which brings us to the listener. Why should you care about some weird particles flying the wrong way up in Antarctica? What's the big deal?
Well, the big deal is this could be, and I mean could be, the first significant crack we've seen in the standard model of particle physics.
Yeah, standard model. That's our current best map of all the fundamental particles and forces, right?
It is. It's been incredibly successful for decades, but we know it's incomplete. It doesn't include gravity properly. It doesn't explain dark matter or dark energy.
So physicists are always looking for cracks, for anomalies.
Exactly. Because historically, that's how breakthroughs happen. Think about the muon. When it was first discovered, physicists were baffled. One famous physicist, I. Rabi, said, "Who ordered that?"
Right, it didn't fit the expected pattern.
No. Or think about the cosmic microwave background radiation, the afterglow of the Big Bang. It was first detected as just annoying background noise in a radio antenna.
Until they realized what it actually was.
And it revolutionized cosmology. These anomalies, these things that don't fit, they often point the way to deeper understanding.
So this ANITA signal, it's not just a weird blip. It could be the universe trying to tell us something profound, something our current theories just don't account for.
That's the hope. That's the excitement. It's a potential sign that our map of reality needs updating, maybe in a big way.
Okay, so let's bring it all together. We've taken this deep dive into these unexplained, upward-moving cosmic rays detected by ANITA over Antarctica.
We've seen why the most obvious explanation, these high-energy neutrinos traveling through the Earth, just doesn't seem to work based on the data from Pierre Auger.
Right, that explanation fell apart, which has forced scientists to peer into the much more exciting, maybe even unsettling realm of new physics.
Possibilities like sterile neutrinos, supersymmetry, maybe even decaying dark matter, things beyond our current standard model.
So, to really hammer home the implications, this anomaly isn't just a puzzle piece that doesn't fit. It's a hint that the whole puzzle box, the standard model itself, might be incomplete.
It really underscores that point. Sometimes the most extraordinary discoveries come when the most mundane explanation fails. It forces us to think bigger.
And it leaves us with this wonderfully provocative thought, which actually comes from one of the researchers involved.
Yeah.
They basically said, look, if penguins haven't discovered nuclear fusion, we might be witnessing the universe telling us something we don't yet understand.
That's a great way to put it. It highlights the sheer weirdness and the potential significance.
So keep your curiosity alive, because discoveries like these little cracks in our understanding, they remind us there's always more to learn about this incredible universe.